Okay, welcome to lesson 2 for week 4 of your distance learning. In the last lesson, we multiplied matrices only 2 by 2s. And today we're going to multiply matrices, but all different sizes. This first part of your notes is a review from the last lesson. All of this. Well, I won't talk about that. I don't want to make this lesson as long as the last one. Let's get straight to the examples. So the first part here that is the review just for your reference. Let's skip straight to the examples. Given the matrices CA and DY, did you see what Miss Arnold did there? Did you see? What does that say? Can. So given the matrices CA and DY, compute the following. I'm actually going to have you do something for every single problem before we even work one. I want you to go through every example on your notes and do that thing where we compare the dimensions. So let's just first talk about the dimensions of each of these matrices. You see they're all different sizes, right? Not all the same like the last lesson. For matrix C, this is 2 by 2. Pause the video, and I want you to write the dimensions for A, N, D, and Y. Pause your video, and then come back and check your dimensions with mine. All right, you should have had 2 by 2, 2 by 3, 3 by 3, 2 by 3, 1 by 3. So if we're trying to do example A, and we need matrix C times matrix A, remember the order matters, so it has to be, you're comparing the dimensions of C first and A second. Do you remember what we're comparing that has to be the same? It's these two inside numbers. It's the columns of the first matrix and the rows of the second matrix. Are they the same? Yes. That means we can actually perform this multiplication. And your answer matrix is going to have these dimensions. Your answer matrix is going to be a 2 by 3. That's your resulting matrix. And remember that I recommended to you to set up your answer matrix before you even do your math. So if there's 2 rows and 3 columns, and your final, that's where all your final answers will go, okay? I want you to pause and take a moment and do this. Here's what you should have come up with for part B. N times D. N is a 3 by 3. D is a 3 by 2. Do the inside dimensions match? Yes. And your answer matrix is going to have these dimensions, a 3 by 2. So there will be 3 rows. Actually, let's make that. And 2 columns. And that's what your answer will look like. Once you do your math, all your numbers will go in those spots. Dn, you should have had that D was a 3 by 2. And that N was a 3 by 3. You compare the inner dimensions. Do these match? No. Therefore, you cannot do this multiplication. You can say it's undefined, which is true. You could write not applicable. You could write can't multiply because wrong dimensions. You don't have to write all those things, just any one would do. Okay, so You don't even have to do that problem. You're done with that one. On the back of your sheet, these are the exact same matrices from the front, so you don't have to worry about figuring those dimensions out again. Y times D, Y we said was 1 by 3. D is 3 by 2. Do the inner dimensions match? Yes. So you can multiply, and your answer matrix will have these dimensions, 1 by 2. So go ahead and set up your answer matrix. It will have 1 row and 2 columns. So that will only have 2 numbers in the answer. And then let's do that for E. You should have done this. Y is a 1 by 3. N is 3 by 3. Do the inner dimensions match? Yes. So your answer matrix has the outer dimensions. So that will have 1 row but 3 columns. And then let's look at F. D squared means D times D. D times itself. And so that's a 3 by 2 times a 3 by 2. Do the inner dimensions match? No. So we cannot multiply undefined. So for those 2 problems that said undefined, you're done with them. There's no math that you can do. But I'm going to work 2 problems with you, and then the rest of the notes you can get from your filled-in notes in your Google Classroom. I'm not going to work A, so I'm going back to the front of your notes. I'm not going to work A because we just did 1,000 of those in the last lesson in practice problems. That was oh no, sorry. Take everything back that I just said. I was thinking that was a 2 by 2 times a 2 by 2. But it's not. Hold on one second. All right, actually, I think I am going to do A for you because when I first looked at your filled-in notes, Miss Arnold has that's a 2 by 2 by 2 by 2, and I was like, I'm not going to do that because we just did a ton of those in the last lesson. But in your filled-in notes, I believe she set that up wrong. So I am going to work A for you so that you have the correct work. So here we go. I'm going to actually clear everything I've written so far so I can make some space for my writing. So CA, we want to do -2, 1, 3, 4 times A, which is 4, 3, 2, 6, 1, 0, right? And I said to set up your answer matrix remember, these have to check, and these are the dimensions of your answer or result matrix. So there's 2 rows, 3 columns. So our final answers are going to go there. We're going to do row 1, column 1 first. So I need row 1, column 1. The first entries of each of those are -2 and 4. And the second entries of each of those are 1 and 6. Okay, so that's -8 plus 6, that's -2. That goes in row 1, column 1. Then now I'm going to stay on row 1, but I'm going to do column 2. So be careful now. It can be real confusing with your eyes and where you are. We're at row 1 and we we've just moved to column 2. What are the first entries in those? -2 and 3. And what are the second entries in those? 1 and 1. So that's -6 plus 1, which is -5. So that was row 1, column 2. That's where I put my answer, row 1, column 2. Let me see if I can erase this red so we can see the next one. Now we are going to move to column 3. Row 1, column 3. What are the first entries? It's -2 in the row and +2 in the column. And what are the second entries? It's 1 in the row and 0 in the column. You're multiplying those together. That gives you -4 plus nothing, which is -4. And that is row 1, column 3. So that goes in row 1, column 3. So now let's move on and fill out the second row of our answer matrix. I'm going to switch over to blue. So now I'm on this row, and I'm going to multiply it by this column first. The first entries are 3 and 4, so you multiply them together. The second entries are 4 and 6, so I'm talking about this 4 right here. This is the second entry in the second row. And then 6 is the second entry in that column. And you multiply them. So 12 plus 24 is 36. I got that by row 1 times column 1, so it goes in row 1, column 1 spot. And now I'm going to move to the second column. I tell you what, if I have to say, by the time I'm done with this lesson, I'm not going to say row or column for the rest of the day. If my life requires me for some reason to have to say that, I'm just going to come up with different words. I'm just going to make up a word. I'm going to be like bobbity and boogity instead of saying row and column. And everyone will just have to suffer me. All right, so here I am. We're going to do second row, second column. Multiply their first entries, that's 3 and 3. Multiply their, oh, sorry, I think I said it wrong. Multiply their first entries, that's 3 and 3. Now multiply their second entries, it's 4 and 1. So that's 9 plus 4, which is 13. And that goes right here. All right, that's all fine and dandy. Fine and dandy for matrices called candy. I'm losing my mind, y'all. This quarantine has got to end. All right. So now let's do row 2, column 3. So the first entries are 3 and 2, multiply. The second entries are 4 and 0, multiply. That gives me 6 plus nothing, which is 6. Okay. So the only other example I'm going to work is one of the back examples. So this was like pretty big, right? We had 2 rows, 3 columns. I've found when students get to the shorter, smaller examples, then they get all lost again. So finish out the rest of the front of the notes by yourself and look at your filled in examples. But right now what I'm going to do is move to the back. And do D. So we already checked the dimensions. Y, we know our answer matrix is going to be 1 row, 2 columns. Let's look at the matrices themselves. We have Y times D. Remember, Y has to be written first. And then D second. So it's kind of weird and counterintuitive that this many numbers is only going to result in that many numbers. but let's talk about why it works like that, okay? So we start the same, row 1 times column 1. The first entries are 2 and 2, so we multiply them. The second entries are -2 and 4, so we multiply them. And then the third entries are 2 and 0, so we multiply them. And what do we do with each of those products? We add them. So this is 4 plus -8 plus 0, which is -4. Okay, that is the product, the dot product I got when I did row 1 times column 1. So that answer goes in row 1, column 1 on my answer matrix. So now let's do row 1, column 2. The first entries are 2 and 5, so we multiply them. The second entries are -2 and -1, so we multiply them. And the last entries are 2 and 3. And then we're going to add those suckers. So this is 10 plus -2 times -1 is +2. When there are several negatives afoot, students make mistakes. So don't add -2 and then times -1. Follow your order of operations here. And then plus 2 times 3, which is 6. And then 10 and 2 and 6 is 18. And so there's your answer, -4, 18. All right. So go ahead and finish out those notes. Check out the work with the filled notes, and then do your practice problems and upload a picture of those showing all of your work to your Google Classroom.